morning, students. Last time we considered uh, center of gravity from chapter 1, that is force. That was section B. Now we are going to go to section C, which is uniform circular motion. First, we will have to understand what is circular motion. So let us try and understand that part. If a particle continues to move on the circumference of a circle, then it is called as circular motion. Very simple statement. Before going to uniform circular motion, part C is uniform circular motion actually. Before that, we have to understand certain terms. So, first term I have explained. If a particle keeps on moving along the circumference of a circle repeatedly, then it is called as circular motion. Whatever time it requires to complete one circle, that is called as periodic time. So, circular motion and periodic time we have to know. Then, what is the direction of velocity for circular motion that we have to understand? See, I will give you one example. If you tie a stone to a thread, this is a stone which is tied to a thread. If it is drilled in circle and at some point this thread breaks, what happens to the stone? Stone travels along the tangent to the circular path at that point. Assume that the stone comes here. Before breaking the thread, stone reaches at this point, and then the thread breaks. Then its velocity is going to be along the tangent. At diametrically opposite point, it will be vertically downwards, and here it will be towards the right. So in circular motion, even if speed of the particle remains constant, its velocity changes. Because velocity is a vector quantity. Speed is a scalar. Speed only has magnitude and its unit. But velocity being a vector, it also has direction. A vector can be changed by 2 or 3 methods. Either change its magnitude, or change its direction, or change both. In this case, even if the speed of the particle, that is, if it covers, say, this much distance in 1 second, next this much distance in 1 second, then we can say that the speed of the particle is constant, but the direction of the speed, that is velocity, is continuously changing. So, if I say velocity changes, how do you define acceleration? Acceleration is defined as change in velocity upon time. Means, in this particular motion, as the velocity is changing, change in velocity is not zero. There is always an acceleration. Now, how we can account for this? Go to Newton's first law. How you define inertia? Every object has its own inertia. Inertia is the tendency of a body to continue in its state of rest or uniform motion along a straight line. Up to what point? Unless it is acted upon by external unbalanced force. So if there is external force acting, then what it can do? It can increase the speed of the particle, it can decrease the speed of the particle, it can change the direction of motion. Here, continuously we are seeing that there is change in the direction. So there has to be some force which is exerted on this particle continuously. As there is change in the direction of motion, there has to be some force, and that force is always along the radius of the circular path towards the center of the circle. This force, which is directed towards the center, is called as centripetal force. Centripetal meaning of the word of this is given at the bottom of that page where this chapter is said. It is center seeking or directed towards the center. So whatever is the force directed towards the center of the circular path, it is called as centripetal force. Now, another question might come to your mind. If this force is acting towards the center, why doesn't the particle travel this way? Why this particle is traveling around the circular path? There has to be some balancing force to this so that particle does not move towards the center. So that force is called as centrifugal. This is a real force. Means there might be a question like distinguish between these two types of forces. What you will be writing? The first you will have to write the definition. The force acting on a particle in circular motion directed towards the center of the circle is called as centripetal force. The force which particle experiences in circular motion directed away from the center of the circle is called as centrifugal force. This is a real force, and this is what is called as pseudo force. Pseudo means false. And this force is real, means we know from where it is coming. Now, in order to understand the existence of centripetal and centrifugal force, we have to imagine a situation which is described in the textbook. So we will be going to that. First, try to understand what is uniform circular motion. Uniform motion, and splitting into two parts. One is linear motion, uniform linear motion. Other is uniform circular motion. So how to distinguish between these two? Linear motion is along a straight line. But when we found a motion to be uniform? If, say, a particle starts from here, covers 5 meters in 1 second, next 5 meters in 1 second, and so on. Means what you are saying, the speed of the particle 5 meters per second remains constant. It covers equal distance in equal interval of time. Similarly, if particle covers equal distance in equal interval of time, say for example, it covers a distance, this is again 5 meters and covered in 1 second. Next 5 meters also covered in 1 second. If this is the way particle is traveling, it covers equal distance on the circumference in equal interval of time. Then it is called as uniform circular motion. Now, in uniform circular motion, we just now said circular motion is accelerated motion. There is always a change in the velocity of the particle when it is traveling around the circumference of the circle. Now try to imagine a situation. I am drawing two diagrams here. Let us assume this is the first diagram. At the center, a stone is tied. I'm using the same characters as used in the textbook so that you can read from the textbook after the explanation. So, the stone is tied to a thread and it is kept on a stationary table. There is one observer standing on the table and there is one observer. They have labeled it as M outside the table. Now, initially this is at rest. This particle will be seen at rest by this person as well as this person because the particle is not moving in any direction. Now, slowly the table is rotated. What will happen? After some time, the particle will reach here. By that time, the person which I am labeling as A dash, person standing here has moved from A to A dash. Where does he see the particle? In front of him. Where he was seeing the particle here? In front of him. What about this person? He sees the particle moving from, I am calling this now as M. Okay, I will call P. And this is position P dash. For person standing on the table, the position of this particle is not changing. Whereas for the person outside the table, the position of the particle changes from P to P dash. Okay. I will consider another position P double dash and person moves to A double dash. Again, from the perspective of the person on the table, the particle is in front of him. Means, indirectly, there is no motion of the particle as far as person A is concerned, who is on the table. But for this person, which is standing outside the table, the particle is performing circular motion. So, what we can say now, there is a tension in the string which we can easily understand. The moment this starts rotating, this will start performing circular motion because of tension in the string. Now, if this force is present, the particle should move towards person A. It does not move because there is onward force which balances the inward force. If these two forces are balanced, the particle will not leave its position. This is what we call as centripetal force, CPF, and this is what is called as centrifugal force. So for the first diagram, what person A observes? Particle stationary. What person M observes? Particle moving in circle. This is for the first diagram. Is person M assuming this outward force? No, because there is force because of which it is continuously changing its position. But from this person's view, this particle is not changing its position because there is a force which is balancing the centripetal force. So that is called as centrifugal force. It arises due to accelerated motion. Sometime back we were talking. Direction of velocity changes means acceleration is there. Therefore, the motion is called as accelerated motion. Imagine the same situation. I am drawing the second diagram here. Now, when the table is stationary, this will observe it stationary, he will also observe stationary. Slowly, the table starts rotating. Assume that the table starts rotating at a faster speed. As the speed increases, tension in the string also increases, centrifugal force also increases, and at a certain point, the string breaks. That is, tension becomes zero. Now, what is going to happen to the stool? I have cut the thread. So, what is going to happen to the stool? It is going to move along a straight line tangential to the circle. This was initial position P. Now it is P dash, P double dash, P triple dash. So for this person, what is happening? This is traveling along the straight line. For the person who is outside the table, if the tension ceases to exist or the thread breaks, then this particle is going to travel along the tangent to the circular path. What about this person? When the stone reaches this point, the person here reaches at A dash. When the stone reaches this point, the person reaches A double dash, and so on for this point, A triple dash. Now, what is happening for this person? It is traveling along a straight line. For this person, the particle remains in front of him here, remains in front of him here, remains in front of him here also, and here also. Means the particle is moving away from him. It is remaining in the straight line along with the person, but it is moving away from that person. Means the particle experiences a force in this direction. That is why it is moving along the straight line and it will always remain in front of him. So for this person, there is no outward force because of which particle moves away. For this person, the particle is moving away from him because the moment this was broken, the centrifugal force took over and it is throwing the particle away from that person. It means that there exists a force which is directed away from the center of the circular path. That force we call as centrifugal force. So this is uniform circular motion. Uniform means traveling same distance, same interval of time. I don't expect a question explain uniform circular motion, but there might be a definition that can be asked. What is uniform circular motion? In other part of this, they might ask you to distinguish between centripetal and centrifugal force, or they might ask you explain the existence of centrifugal force in circular motion. So here we complete chapter 1. Now we are going to start with chapter 2, which will involve lot of numericals. So we have to know the formula. We don't have to derive the things. It is both power and energy. So that I will start in the next lecture.